The last time, we look at how temperature transmitter can be calibrated. A demonstrated example was done using dry block and decade box resistance method. In today's series, we will be looking at how pressure transmitter can be calibrated. Stay tuned.
Hey Brew. I could see you were so busy yesterday. I tried to catch your attention, but I could see that the task you were doing kept you overwhelmed. Hope it went well.
Yeah. Sorry about that. I was busy carrying out basic maintenance, which is to basically carry out program backup, and to also look for areas that need improvement. Most time I tends to put all I have. And couple with the festive period that is approaching, there should not be any room for breakdown.
Oh, I see. Maintenance is very key.
How about yours?
Well, mine was stressful as well. Couple with the deadline I had to meet. Immediately I left your workstation. I went straight to executing the task at hand. Taking inventory of the spare. Looking at the breakdown analysis for the month. Mike, working on this data can be very demanding and at the same time tasking.
Yeah. I can imagine. I just hope you had a way of refreshing up when you got home.
Well, I was lucky. My team was playing, so I resort to watching my team play afterward.
I just hope the outcome of the match was in the favor of your team. Because after a difficult day, the last thing one will want is bad performance from a team you support.
Well, early on, the match was one-way traffic. The opposition was played and pressed in their half. But after the hour mark, things change. The match becomes end-to-end. And things took a turn for worst. When one of our defender committed an home goal. That goal was the straw that broke the camel back. Because afterwards, they kept conceding. It got to a point that I stopped watching the match. You are making jest of me.
No. I am not. In soccer you win some and lose some. What is that?
It sounds like a sudden depressurization of gas.
Could it be the process tank? It better not be.
There is need to investigate.
The quick exhaust valve is active. No wonder the venting sounds. But the modulating valve is meant to open at varying range in response to the pressure within the tank.
Let's check the trends on the HMI. Because the pressure transmitter will not give us the value we need at the moments. With the pressure trends, we will have a better understanding.
From the trends, the pressure of the tank has not even exceeded 3 bar. This is far below the quick exhaust venting pressure. Because, as per the quick exhaust operating pressure, it is meant to be activated at 7 bar. So the pressure is still within its permissible range. Because I know what I wrote in the program. By design, the modulating valve is meant to open and close at interval in response to the tank pressure. This is done in order to keep the pressure of the CO2 at 4 bar. We need to retrieve the pressure transmitter, and check the current and pressure ratio with the commissioning document. This way, we will have a better understanding of the pressure transmitter at varying pressure.
These things happen in process plant. Air and CO2 pressure is an integral part of a process and robotics equipment. Having the right amount does not only equate to product quality, It also enhanced perfect actuation of robotics part. Hence the importance of well-functioning pressure transmitter. Again, the importance of CO2 can be felt during opening of carbonated drink. The unique sound gotten is an example of a quality product. CO2 also has a unique features, which is the product shelf life. Because apart from the unique sound that naturally comes with carbonated drink when opened, CO2 also serves as a protective measure that keeps the soft drink fresh and prevents the growth of bacteria in the liquid while stored. So basically, when we have less of it in a stored liquid, there might be a lot of bacterial activities within a carbonated drink, and as such the shelf life of the product will be affected. And having too much of it can result to bottle burst. Hence the need for it to be regulated. And this is done through a well-functioning measuring equipments. Now let's look at the state of the transmitter. The transmitter is connected in series with the digital multimeter. Again, let's do a quick recap. Pressure transmitter is a process equipment that convert pressure to electrical signal. The transmitter send a varying DC current to a programmable logic controller, also known as PLC. If you want to learn more, you can check one of our series on pressure transmitter. A detailed explanation was made. Now, let's understand the state of our pressure transmitter. So the current signals will be gotten during measurements and calibrations. At 0 bar, the current gotten is 3.4 mA. At 1.25 bar, the current gotten is 4.1 mA. At 2.5 bar, the current gotten is 8.67 mA. At 3.75 bar, the current gotten is 13.45 mA. At 5 bar, the current gotten is 18.67 mA. From the data gotten, the transmitter will now need to be recalibrated. We will be starting with the lower limit. At 0 bar, we will vary the current until it level up at 4 mA. For the upper limits, which is at 5 bar, we will vary the current until it level up from 18.67 mA to 20 mA. Now that the transmitter has been recalibrated, let's authenticate our transmitter. At 0 bar, the current gotten is 4 mA. At 1.25 bar, the current gotten is 5 mA. At 2.5 bar, the current gotten is 10 mA. At 3.75 bar, the current gotten is 15 mA. Finally, at 5 bar, the current gotten is 20 mA. Again, it is always very important to pay a very good emphasis on the commissioning documents, because machine designer have a specific current to pressure range as per the program requirements. Let's do a quick recap. We started off with a typical plant setup. We look at how pressure transmitter can be recalibrated by applying manual pressure. And we ended off looking at the importance of commissioning sheet during calibration. I hope you have enjoyed this series. See you in the next one.